Hello everyone. Previously we had discussed about the open or closed principle, right? Also we saw the same thing. We tried to implement it. We saw the same thing with a very simple example. I hope that concept is completely clear. Today we'll be discussing about the Liskov substitution principle, nothing but the LSP or L in the solid principles, right? So basically what it states, objects of a superclass should be replaceable with objects of its subclasses. Again, I'm telling this is very simple. Objects of the superclass should be replaceable with the objects of its subclasses without altering the behavior of the program, right? So objects of the superclass should be replaced with objects of the subclasses, mainly without altering the behavior of the program. This we have to keep in our mind. Let's go with the base class initially. So let's try to implement the same thing with the example. Let's try to understand the same thing with the example first. So I'll initially go with the base class, nothing but the shape here. I'll just give here shape. So within this one, let me make use of the method get area. So here, let me quickly come here. Let me give here new error. Let me give here method not implemented. This is fine. I'll just come out of this class entirely. Next, let's make use of the subclass for the rectangle. Subclass for the rectangle means I'll just be going with the class rectangle here, the name. We are making use of the subclass for the rectangle, right? So which basically extends the parent class, nothing but shape. So here within this one, I'll just make use of the constructor. Within the constructor, let's pass the parameter width and height. So here, I hope this is clear. Let's make use of the super keyword here. And let's assign the width and height, right? I'll just give here width equals width and height. Let me set this height to height. So this is fine. I'll just come out of the constructor. Let's go with one more method, nothing but get area. So within this one, let's just return the formula, right? So how to calculate the rectangle? This one has to be returned here. Return. The formula is nothing but width into height. I'll just give here width into height. This is fine. Let me come out of this class entirely. The subclass rectangle entirely, right? Let's write, I'll just make use of one more subclass for the square, right? So I'll just quickly copy this entire thing and make the necessary changes, whatever that is required here. So instead of the rectangle, let me make this one square. This is fine. This is extending the base class shape. This is fine. Here within the constructor, instead of this one width and height, I need only side. Basically we are going with the square, right? I just need the side. This super keyword remains same here. So here let me completely remove this line. This one I'll just make this one whatever I have considered parameter I have given side. Let me assign this one to the side. This is fine. And here this will be get area itself. Here the formula will be different. Here this dot side into this dot side. Side into side area for the square. I'll just entirely come out of this class. So next, let's write the function that basically uses the base class. So let me quickly create the function here. I'll just name this one print area. So within this function, let me pass the parameter shape and quickly log something here. I'll just give here console.log of function for using the base class. Basically this is one, right? So what shall I give here? Let me give here area. Within this one, let me give shape dot get area is this one, this method we have made use of, right? So let's use this one. So this is fine. Next, I'll just come out of this function. Let's try using the subclasses now. Here I'll just give rectangle, and let me give here, sorry, this has to be rectangle. Let's pass the parameters. Two parameters we have here, right? So one is width, two parameters we have here. So let me pass some two random numbers here. I'll just give here 4 and 5. So next, for the square also, let's do the same thing. I'll just give here square, new, this one square. We have only one parameter, that is side. I'll just be passing some random number here, 3. So let's call the print area function, and let's pass the rectangle here, this rectangle mainly. And same thing, again print area function, and this time let's pass the square here. So we have passed 4 and 5. The formula is nothing but width into height here, right? And this one is side into side. Basically this has to be 20 and this has to be 9. So 20 and 9 we need to get here as output, right? So let's try running code. Let's see what output we get. Yeah, area 9, area 20 and area 9. This is what we are getting, which is absolutely correct, right? So I'll quickly explain what I've done here, the code part. Let's come to the this one code part. So initially we are making use of the shape class. You can clearly see here we are making use of the shape class, which defines a generic get area method. So we can clearly see here we are making use of the shape class. Also it is a base class which is making use of the generic get area method. And rectangle and square, this is the subclass of the shape, right? A rectangle and square here, this overrides the get area. You can clearly see here this basically these two subclasses, this overrides the get area method with specific implementations. We can clearly see here, right? And also finally the print area function works seamlessly with both subclasses adhering to the this one print area function, whatever I have written here. This one, this function works seamlessly with both subclasses, basically adhering to the Lisco substitution principle. So what it I explain something about the Lisco substitution principle, right? So it states that the object of a superclass should be replaceable with objects of its subclasses. That's what we have done here. Object of the superclass should be replaceable with the objects of its subclasses. Clearly that's what we have done here without adhering the without altering the behavior of the program. We haven't altered any behavior of the program, right? So this basically the print area function is working seamlessly here with both the subclasses. One is square and one is rectangle, adhering to the Lisco substitution principle. I hope this concept is completely clear. We saw this one with the example, right? So I hope this concept is completely clear. Next, we'll be discussing on the interface segregation principle, nothing but ISP or I in the this one solid principles, right? So for now, this is it. Thanks for watching, guys.